First thing that you need to know, you've already talked about rational numbers before. We've seen them, we've talked about them. You've got your whole numbers, positives and negatives. Zero is considered to be a rational number. You've got decimals and fractions that are rational numbers, but it's important to know that when it's in fraction form, it must be able to convert into a decimal that can terminate or repeat. That's what makes it rational. If it converts into a decimal that does not terminate or does not repeat, that makes it an irrational number. So I'm going to give you guys a chart to show you what makes that split for rational numbers and irrational numbers. So the first idea that you have this section that we call all reals. So we have our real numbers. That's basically everything. Everything in there is going to be considered a real number. We'll talk about imaginary numbers if we have time. If we don't have time, you guys will get into imaginary numbers later on when you get into the algebra classes. But our primary focus is the idea of real numbers. And real numbers is split into two components. You've got rationals and you've got irrationals. So like I've said before, rational numbers you've seen. You know what rational numbers are. Your rational numbers are things like 1/2, 0.25, 0.7, where the 7 repeats, negative 2/3. Okay, these are all considered to be rational numbers. Inside of those rational numbers, because you've got more than just that, you've also got what's considered to be integers. And every single integer is also considered to be a rational number. And our integers are things that are negative or positive whole values. So -3, a +2, a -7, a +4. Okay, these are considered to be integers, but they're also called rational numbers. They sit inside the rational number unit. Then you've got still in here, you've got what's called your whole numbers. Your whole numbers. Those are things like 0, 2, 10. Those are all positive values, including 0. And then you even have something in here called natural numbers, which is just 1 and up in whole number increments. Now, beyond this scope, you also have your irrational numbers set. And the irrational number set is just its own individual set inside of the real numbers. And with our irrational numbers, you have values like pi. Pi is considered to be an irrational number. It's probably one of our more famous ones. And then you've got what you're going to see today, starting in this unit, roots that are not perfect. So instead of like square root of 1 or square root of 4, maybe square root of 2. That's not a perfect square. Therefore, it is an irrational number. Cubed root of 5. Again, it's not a perfect cube. Therefore, it is an irrational number. Any value that when it's in a decimal form does not repeat, it just keeps going on and on and on in no particular pattern, that's considered to be an irrational number. It doesn't repeat and it doesn't stop. So what you need to be able to do is identify the difference between rational numbers and irrational numbers. And you need to be able to categorize numbers as, you know, oh, this is not just a real number, but it's rational, which makes it an integer, which makes it a whole number, or this is only an integer, which makes it also a whole number, that kind of thing. You need to be able to identify what number sets do these items belong to. So let's go ahead and do a quick practice on that, and then we'll move into our roots. All right, so given the following, we've got 0.25, 25, 25, and then dot, dot, dot. So what set does this belong to? So the first thing you identify is that these are all going to be real numbers that I'm giving to you. So you don't have to put down that it's a real number. Identify all sets of the following, I'll say the following real numbers belong to. So you don't have to identify that they're real. We already know it's a real number. But the first thing you want to identify, is it rational or irrational? Rational. So we know that it's a rational number. So because of the fact that it is a rational number, we now need to look at the rest of the set. Is it also an integer? No. It's not an integer because it's not a whole number value. So rational number is the only thing that you're going to be able to identify it as. Rational number. Okay, let's take a look at another one. 0. Is it rational or irrational? Rational. Can it be called an integer? Yeah. Because where does 0 fall into? Where did our zeros fall? In the whole number. Because of the fact that the 0 is a whole number, it means it also is inside of integer, and it's also inside of rational. So it fits all three of these categories. So you need to make sure that you identify all types of categories that it can fall into. Square root of 3. Where does that belong? Emiliano? Irrational. It's not a perfect square. Since it's not a perfect square, it makes it an irrational number. If you were to type in square root of 3 in your calculator and hit enter, it will give you a long drawn out decimal that does not terminate and it does not repeat. So it's an irrational number. Last one. Negative square root of 16. Is that a perfect square or not? It is a perfect square. So is it irrational? No, it's going to be rational. It's a perfect square. What is the square root of 16? 4. But since we have a negative on the outside, what is that going to make this? A negative 4. So we know that this value here is going to actually be equal to negative 4. So now we just have to see what categories does negative 4 fall into. Does it fall into whole numbers? No. Whole numbers have to be what? Positive. Does it fall into integers? Yes. So we know it's an integer. And since it's an integer, it's also rational. So you'll be doing that today on your homework. That's also going to be one of the IXLs that's assigned for tomorrow. Identifying whether it's a rational or irrational number. Emiliano? Perfect square means that when you take the square root, you get a whole number or a perfect value. It doesn't necessarily have to be a whole number. Like 2.25 The square root of 2.25 is going to be 1.5. That's technically a perfect square because it has a rational number that is its root value. So it makes it a perfect square. Fernando, did you just check me? He's like, I don't believe you. All right, let's move on to roots. So when we talk about roots, that's when we're talking about having the root sign. So this root sign that you're seeing on your calculator and on your assignments from now on, this is called our radical sign. So you'll also hear me calling them radicals, especially if they're not perfect roots, if they're not perfect squares or perfect cubes, then that means that they're going to be radicaled values. But they can still sometimes be simplified, which we'll talk about that later on too. But this is your radical sign. And all roots have two values. All roots have two values unless otherwise indicated. So what I mean by that, if I say that you take the square root of 100, all of you know that the square root of 100 is what? 10. But did you also know it's negative 10? Because negative 10 times negative 10 also equals 100, doesn't it? So whenever we ask you for a perfect root, if it doesn't have a value in the front, like if it doesn't have a negative in the front or a positive in the front, then that immediately lets you know that there are two roots. There are two possibilities. It could be a positive 10 or it could be a negative 10. So we always put it as an answer of plus or minus. So positive and a negative on top of each other. And then the root's value, 10. Now, sometimes we will indicate to you that we only want a specific root. So if I were to indicate a negative square root of 25, then that means I'm only looking for one root. What kind of root am I looking for? A negative 5. And again, they don't always have to be whole numbers. They don't always coming out to be a whole number. So if I say a square root of 1.21, that again, because I haven't indicated anything, that could be a plus or a minus, and that would be 1.1. Because 1.1 times 1.1 is 1.21. Now, the way that you can identify, now your calculator will only tell you the positive root. Your square root symbol is right here in green. So what do you have to press first to get that root symbol? Second. So if you hit second and hit the symbol, then you can type in 1.21 and enter, and it'll tell you 1.1. Okay, now there are different modes that you eventually are going to want to switch this to. So for example, if I were to go ahead and type in the square root of 3, it's just going to pop in square root of 3 right now. It's not going to give me a decimal form for it. You'd still have to be able to hit the bottom down here to convert and see what the decimal format would look like. And then it'll get you a portion of your decimal answer. But this is why, again, it makes it an irrational number. Keeps going on, doesn't have any repetition, doesn't have any kind of pattern. Okay? All right. Why don't you guys go ahead and tell me what you think this is going to be. What do you think? 6 over 13. You have to take the root of both the top and the bottom. When you've got the entire fraction inside of the radical, then that means you're taking the square root of 36 over the square root of 169. And again, positive and negatives, it could be either or. So I would put a plus or a minus. Square root of 36 is going to be a 6. Square root of 169 is going to be a 13. So it's a plus or a minus 6 over 13. Okay, let's go on to the back page, or the next page, page 2. So square root of 30, is that a perfect square? No. This is not considered to be a perfect square. So instead, what we can do right now is we're just going to estimate it. Now, there's 2 ways you can estimate it. If I let you have a calculator, then you could estimate it using the calculator, can't you? You could type in square root of 30, hit enter, and then hit the conversion sign to the decimal. And then you would get 5.477225575. That's one way that you're able to go ahead and estimate it. Some people might say it's 5.48 or it's 5.5, or they might just say it's 5. Another way, though, is if they say that you can't use a calculator, which you will have a quiz without a calculator and you will have to estimate. So when you're estimating non-perfect squares without a calculator, what you have to do is you have to find the 2 perfect squares that it falls between. So square root of 30. What perfect square happens to be smaller than the square root of 30? 25. 25. So we have the square root of 25 is a perfect square that's smaller than 30. What's the next perfect square after 25? 36. So we have square root of 36. That's the next one past it. So now we just need to identify how big the gap is between these. The gap between 25 and 30 is how big? It's a gap of 5. What about the gap between 30 and 36? It's a gap of 6. So it's closer to 25 than it is to 36. It's closer to that square root of 25. And square root of 25 is what? 5. So that means that we approximate that the square root of 30 is approximately 5. We know it's not exactly 5. It's approximately 5. That's the way that you would estimate without the use of a calculator. You identify the perfect squares that are around it, see which one it's closest to, and go with that. And that was number 5. All right, I want you guys to do these ones on your own. And for all intents and purposes for right now, we're just going to focus on the positive root. For right now, we're just going to focus on the positive root, unless it's otherwise stated. Like number 7 is otherwise stated. All right, who can tell me what they got for problem number 6? Brent? 3/5. Very good. Yeah, I was like, wait, what? Okay, yeah, 3/5. So if we take these down, the square root of 225 is going to give you what? What's the square root of 225, guys? 15. So the square root of 225 is going to be equal to 15. The square root of 625 is 25. And then when you simplify it, it would, since they're both divisible by 5, you would get 3/5. And again, we're just going to focus on the positive root. Okay? Yes. It's, well, I mean, one, you can use your calculator, but if you don't have a calculator, it's just about memorizing. It's the idea that we know 15 times 15 equals 225. Okay, so all a root is, the root is the exact opposite of squaring a number. So when you square a number and then take the square root of that value, you get the number back. So like 3 squared is 9, square root of 9 is 3. Okay? All right, number 7, negative square root of 400. Jimmy? Negative 20. And then number 8, the square root of 54. Is that a perfect square? No. What perfect squares are around it? 49 and 64. So square root of 49, which is 7, and square root of 64, which is 8. So we know it falls somewhere in between there. 54 is closer to 49 or 64? Which one is it closer to? To 49. It's closer to the 49 than it is to the 64, so that means it's approximately 7. It's approximately 7. Yeah. Again, it's just about memorization. You have to have it memorized. That 54 is just not one of those perfect squares. Again, perfect squares, so if you know your numbers real quick, like, okay, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So that's making, 4, 9, 16, 25, 36. Those are all my perfect squares because I'm squaring each of these numbers consecutively, okay? So I know 7 squared is 49 and 8 squared is 64. That's why those two are my perfect squares. Nothing squared is going to give me 54, okay? All right, let's talk about cubed roots now. So again, you don't just have a square root, you have an nth root. That means that you take a root to an nth power. Okay, so I can have a 4th root, a 5th root, a 6th root. All it just basically means is you're breaking it down to how many times you multiply the same number over and over and over again to get this value inside the radical. So if we've got a cubed root, that looks like a square root symbol, but with a 3 on the outside in front of it. That means you're taking that cubed root value. So a cubed root of 125 is going to be equal to 5. Because 5 times 5 times 5 equals 125. Now, what's different with cubed roots that you can't do with a square root is you can have a negative inside of the radical. With a square root, if you try to take a square root of a negative number, you're going to get an error because those aren't considered to be real numbers. Those are considered to be imaginary numbers. But if you take a cubed root of a negative number, like cubed root of negative 64, that's okay. In fact, the cubed root of negative 64 is going to be negative 4. That's because negative 4 times negative 4 times negative 4 will equal a negative 64. You can multiply 3 negatives together to get a negative answer. So it's okay to have a negative inside. And just like square roots, you can also have cubed roots of fractions. So cubed root of 216 over 343. You would just break it down into its components. That means you take the cubed root of 216 and individually take the cubed root of 343. And again, you just have to have these memorized. The cubed root of 216 is going to be 6, and the cubed root of 343 is going to be 7. Again, because 6 times 6 times 6 equals 216, and 7 times 7 times 7 equals 343. Now, as I've been saying over and over and over again, the opposite of a square is a square root. So if you get a problem like x squared is equal to 196, in order for you to be able to solve it, your inverse operation is to take the root. So the inverse of a power is a root. So if the power is squared, then it's a square root. If the power is cubed, then the inverse is a cubed root. If it's a fourth power, the inverse is a fourth root. So all I would have to do here is take the square root of x squared, which would give me x, gives me x by itself, and then I take the square root of the other side, square root of 196, which is going to give me a 14. So x will be equal to 14. Both positive and negative. Can I go on to the other side? Okay, so if I give you x to the third power is equal to 8, again, your inverse is going to be a cubed root. So that means you need to take the cubed root of x to the third power and take the cubed root of 8. The cubed root of x to the third power just gives you x by itself, and then the cubed root of 8 gives you 2. So x would be equal to 2. Now again, as I stated before, when we're talking about square roots, the negative square root of 16 is not the same thing as a square root of negative 16. These are not the same thing. For the square or the negative square root of 16, that's going to come out to a negative 4. Square root of 16 is 4, and having the negative on the outside gives you that negative 4. But the negative inside the radical, so square root of a negative 16, actually comes out to what we call 4i. This is an imaginary number. So it's not a real value. And you don't have to get into this. So if you come across a problem currently in your unit where it has a negative inside of a square root, not a cube root, but a square root, then you know that it's not able to be done at the time because these are imaginary numbers. And imaginary numbers are real simple. It might sound like it's real difficult, but there's just a repetition that occurs. You only have 4 types of imaginary number sets that are occurring. So I'll even show it to you real quickly. So the value I is represented as the square root of negative 1. That's why we can pull the -1 out from inside here and call it I, and then we just take the square root of 16 to give us 4. So it's 4I. Then you've got what's called I squared, and I squared is considered to be just a -1. Because if you do square root of -1 times square root of -1, you just get -1. Then you get I cubed, which is the negative square root of -1. And then I to the 4th power, which is considered to be just a +1. And then it repeats. So like I to the 5th is is the square root of -1. I to the 6th is -1. I to the 7th is the negative square root of -1. It just keeps going over and over and over again. Again, you'll get into this much later. Any questions? All right, you have an assignment tonight. The assignment is lengthy, but it's not due until Monday when I see you guys. I'm not seeing you on Friday unless I decide to pop by and just disappoint you so badly, Omar.
What?
Mm-hmm. Yeah. Mm-hmm. Okay. All right, so let me go through this real quickly with you. On the front, problems 1 through 12, you're just identifying what the root value is going to come out to. If it doesn't have anything in front of it, then it's a positive answer I'm looking for. If it has a negative in front, it's a negative answer I'm looking for. If it has a plus or minus in front, then it's a plus or minus answer I'm looking for. Okay? Problems 13 through 18, you're solving for the variable. So if it's a squared value, you take the square root. If it's a square rooted value, what inverse operation do you need to do? You need to do the exponent. So square it to get the variable by itself. Okay? Then you've got a couple of word problems. For problems 21 through 23, they're giving you the area of a square and they want to know the perimeter. So in order to find the perimeter, you need to know what the side measurement is. So if you know the area of the square, how do you find the side measurement? What do you need to take? The square root. Take the square root of the area, that'll give you the side measurement. Once you know the side measurement, all you have to do is multiply it by 4, and there's your perimeter. On the back, you're estimating to the nearest integer. That means I want the nearest whole numbered value. So you're going to do what we did. Find the 2 perfect squares that it falls between and which one is it closest to. All right, problems 32 through 34, you are placing these in order from least to greatest. That means that you are going to need to identify using your calculator what is it in its decimal format and then put them in order from least to greatest. And then 35 through 42, you're identifying what type of real numbers they are. Are they rational, irrational, integers, whole numbers? Name all sets that it can belong to. So if it's a whole number, then you also have to indicate that it's an integer and that it's rational. You don't have to indicate that it's a real number because I've already told you that it is. 43 through 48, greater than, less than, or equal to, or sorry, less than, greater than, or equal to is what you're identifying here. And then, of course, a couple other little word problems on the bottom. And then it's done. Not due until Monday, but you do have IXL tomorrow. So you won't be having all class periods work on this tomorrow.